Okay, here you go. These are the rest of the free response questions for vector motion in 2 dimensions, vector functions in general. Number one here, I'm going in the order that they showed up on the sheet that I gave you. So this is 2005 Form B, number one. An object moving along a curve in the xy plane has position x of t, y of t, and a time t greater than or equal to 0. These are the derivatives, so these are the velocities, x velocity, y velocity. At time t equals 0, the object is at this position, so that's its x coordinate and its y coordinate. At time t equals 2, the object is at point P with x coordinate 3, so 3 comma something we don't know. All right, find the acceleration vector at time t equals 2 and the speed at time t equals 0. All right, so the acceleration is equal to, the acceleration vector would be equal to, let's see, it would be the derivative, the x coordinate would be 12 minus 6t, right? And that's the derivative of the velocity function, it's second derivative of x. And then the derivative of the y coordinate is going to be 1 over 1 plus t minus 4 to the fourth times the derivative of what's inside, which is 4 times t minus 4 to the third. But you don't actually have to do that, because to find the acceleration vector at time 2, we could use our calculator, and let's actually do that. Calculator out. So let's go ahead and clear all that out of there. Make sure that we are in, let's see, we're in parametric mode. Maybe we'll need that. We'll see what, we're just going to do something on this screen for now, so we'll see. So, I mean, it would be certainly easy to just plug 2 into that, right, which is going to be 0. But remember, when you have your calculator active, you can always do math and deriv, which is number 8, and we're finding the derivative of 12t minus 3t squared, comma, it's giving me t's here because I'm in parametric mode. It doesn't matter if you were in regular mode and those are x's, it doesn't matter, you get the same answer. And we're evaluating that at 2, right? And of course that should give me 0. And then also, again, to do this one may be better to do with calculator because, well, it's a little more complicated, right? So math 8, and then we want the derivative of natural log of 1 plus t minus 4 to the fourth, comma, t comma 2. And that is 2-3 College Board decimal places, negative 1.882. Negative 1.882. There's the acceleration. Now we want to find the speed. So the speed is the absolute value of the velocity. So let's see, the velocity would be just plugging 2 into those original functions. So that's 12 times 2 is 24 minus 3 times 2 squared. That's 24 minus is 12, isn't it? And check my work there. Make sure that that's right. That's 12 times 2 is 24 minus 3 times 4, yep. And then the y coordinate would be, let's see what we get when we plug 2 into 2 minus 4. Sorry, let me put that on screen. 2 minus 4 is negative 2 to the fourth power is positive 16. 1 plus 16, so that's a natural log of 17, whatever that is. And then so the speed is the Pythagorean theorem applied to that. So let's go ahead and do that. I'm looking for the square root of 12 squared plus the natural log of 17 squared, and that gives me 12.330. 12.330. Okay? And, all right, enough time spent on that. The y-coordinate of p. Well, let's see what we know. I only have the derivative here, so if I want to get back to information about y, I have to take the antiderivative of this. So to get the y-coordinate, this was part A, this is part B. I'm going to take the antiderivative of dy dt, right? And that's going to give me, from where to where? Well, I want to find out, I want to know about the y-coordinate of p, and p is when it's at time 2, and I know about time 0, so I'm going to go from 0 to 2, right? Because this is the one I know about, and this is the one I want to know about. So that is equal to, by the fundamental theorem of calculus, that would be y of 2 minus y of 0, right? The antiderivative at this minus the antiderivative of that. So let's see, this I can evaluate with my calculator. So I'm going to do the integral from 0 to 2 of natural log 1 plus t minus 4 to the 4th dt. That's equal to y of 2, that's what I'm trying to solve for, and y of 0 is 5, right? They gave us that. Remember, that comes from this. At time equals 0, those are the x and the y. So at time equals 0, that's 5. So let's just figure out what this is, and then we have to add 5 to that, and then we should have our answer. So again, I'm going to do this with my calculator. So I want to do math 9, that's fn int. I want to find the integral, natural log 1 plus t minus 4 to the 4th, and close, one more close there, I think that should be right, comma t, comma from 0 to 2. And that gives me 8.671, and then I'm going to add the 5 to the other side because I want to know the y-coordinate at 2 plus 5, gives me 13.671. So y of 2 is 13.671. Listen, this trick, like doing this fundamental theorem of calculus thing, that comes up in all 3 of these problems. So if you didn't get that part, before you watch the video and watch me do this exact same thing a couple more times, you need to go back to those other 2 problems and try to rework those parts where you have to do this. Okay? And you can use this as your model, but you should definitely have practice doing that because you will see that. You will be expected to do that on the real test. Write an equation for the tangent line to the curve at point P. Well, to write a tangent line, I need a point and I need slope. So I now have the point. The point is, excuse me, the point 3, they gave us the x-coordinate, comma 13.671. That's the y-coordinate that I just found. And the slope is dy dx, which is, did we already find the speed? We already found these ones. They actually asked us already to do these at 2, right? This was at 2, so plugging 2 into the 2 derivatives, we got this and this. So the slope is natural log 17 over 12. Right, you can plug them in again, but I mean, plug them into the same thing. So that is what we got for those. So what's the equation for the line? Let's just write it in point-slope form. Y minus 13.671 is equal to the slope times x minus 3. So we actually had all the information. We had already, we got the y-coordinate here, so we had the point, and we had already found these 2 pieces of dy dx, right, from part A. So that was quick. Excuse me. For what value of t, if any, is the object at rest? And then explain your reasoning. Well, I'm going to show you what I'm going to do to figure that out. The object would be at rest only if Actually, I don't need to delete those. Let me just go back to function mode. And the object's at rest only if both velocities are 0. Right? Because even if one of them is 0, it could still be moving up and down. Or if the y velocity was 0, it could still be moving back and forth. So only if both of these are 0. So we have to figure out where are they both 0? Well, this is easy enough to figure out where those are 0. This factors into 3t times 4 minus t, right? So that's going to be 0 only at 4, right? So, or 0, actually. So, dx dt is equal to 0 when, let's see, what did I factor in? That's 3t times 4 minus t. So that's at t is equal to 0 and 4. Those are the only possible places, or the only possible times, I should say, when t equals 4, because those are the only places here. So now we just have to check those here and see if either one of those gives us a 0. Looks like plugging 0 in definitely won't, but plugging 4 in, 4 minus 4 is 0, to the 4th is 0, natural log of 1 is 0. So, and dy dt is equal to 0 at t equals 4. So the object is at rest when t is equal to 4, because both of these are 0. Right? Not too bad. All right, it took us 12 minutes. Let's move on. See if we can get them all done in about half an hour. I'll try to move a little faster for the next one. Okay. Bottom of the page. This is 2004 Form B, number 1. They looks very similar to the last one. We've got the dx dt and dy dt curves for all real values of t, so t can be positive and negative, and at time t equals 0, the particle is at the point 4,1. So there's an initial condition again. Excuse me. Find the speed of the particle and its acceleration vector at time t equals 0. Oh, this is familiar. So speed is equal to the square root of the velocities squared, right? We're doing the Pythagorean theorem on that. And we're doing this at time t equals 0. So 0 plugged into dx dt gives me 3, plus, and then 0 plugged into dy dt gives me, plugging 0 in for those makes both the e to the whatever is 1, so that gives me 7 squared. So that's equal to, that's 9 plus 49. This is square root of 58. You can do that with your calculator. This is a calculator problem. You can give the decimal version of that. It's up to you. Excuse me. Now, acceleration. I'm going to go back to my calculator here. The acceleration vector, so I should put at time at 0 is equal to, so let's see. I want to find the derivative of this at 0 and the derivative of this at 0. And I'm going to go ahead and do that with my calculator. You could do it without, but just for practice. So math 8, I want the derivative of the square root of, it's going to give me x's now because I went back to regular mode, but that doesn't matter. So the 4th plus 9, comma x, comma 0, and that's 0. And I think I can remember that. And then n deriv, math 9, math 8, with the derivative of 2 e to the t plus 5 e to the negative t, comma x, comma 0. And that's negative 3. This is calculator error here. It's actually exactly negative 3. But anyway, you'd have 3.000 if you were rounding correctly. So So the acceleration vector is 0, comma, -3. You could have found that without your calculator, easy enough. Part B. Find an equation of the line tangent to the path of the particle at time 0. All right, we need a point, which they gave us, and we need slope. And I think we have the elements, the pieces of the slope, right? So the equation of the line tangent to the path of the particle at time 0. The point is 4, 1, and the slope is dy dx, which is dy dt over dx dt, which is this over this, 7/3, right? So the equation of the line is y minus 1 is equal to 7/3 times x minus 4. Again, we had a lot of that information already. Part C, find the total distance traveled by the particle over the time interval from 0 to 3. All right, total distance traveled, we do the integral from 0 to 3 of this, basically, the Pythagorean theorem of the applied to the velocities for each piece. So this would be dx dt is t to the 4th plus 9, the square root of that squared, plus 2e to the t plus 5e to the negative t squared dt. That's how we find total distance traveled, right? So it's also known as the length of the curve, right? So let's see if I can get that in my calculator without messing it up. Certainly you want to write that down because that's probably worth a point to have that. So let's see, I'm going to go math 9, FN int. My function is the square root of that square and that square root cancel out. So put in t to the 4th plus 9, right? So this parentheses here, that just opens the big square root sign, right? That's like a set there. So that's this piece. Now plus 2e to the t plus 5e to the negative t. That just closes that exponent, and then another one close, and then, oops, I think I needed a big parentheses here, and I didn't put one there, so I'm going to go back here and insert, oops, and I did that backwards, so I need the plus, there we go. Right, I need a big set of parentheses around that whole thing. So that looks good now, and now I'll square that, right, and then another close. So just be careful with those. Make sure you can get that all entered in right. Comma x, comma, going from 0 to 3. And calculator says that that's 45.227. All right. That's the total distance traveled from time 0 to 3. Part D. Find the x-coordinate of the position of the particle at time 3. Okay, that is like part B of the last problem. So if you didn't get this, I want you to go back and look at that part and try this one on your own first. Now, we're going to use the fundamental theorem of calculus. There need to be 2 points involved here. We're going from 0 is the point that I know about, right? And 3 is the one I want to know about. Okay? I'm trying to figure out the x-coordinate. So I'm going to take in here, I'm going to have dx dt, which is the square root of t to the 4th plus 9 dt. And that's equal to the x-coordinate at 3 minus the x-coordinate at 0. Right? Because this is dx dt. The antiderivative would just be the x function, the x position. Right? That's a fundamental theorem of calculus. Antiderivative of this equals x of 3 minus x of 0. The good thing about this is I know this one, and I'm looking for that one. So that means x of 3 is equal to this, which I'm going to do in my calculator in a second, plus x of 0, which is, what was that x coordinate? 4, right? So let's do that. So I want to do math 9 fn int the square root of x to the 4th plus 9 comma x comma 0 comma 3. That's 13.931. Just make sure I got all that in right. Yep, that looks right. And then I need to go ahead and add this over to the other side. So I'm adding 4 because they told me that at time 0 the particle is at 4, 1. So that's the x coordinate at 0. So plus 4. That's 17.931. All right. The last problem on the other side. We've got an object moving along a curve in the xy plane, x, y, and y of t, and they're giving us dx dt is this, and the derivative dy dt is not explicitly given. At time t equals 2, the object is at position 1, 8. So at 2, it's at x equals 1 and y equals 8. They want us to find, first of all, find the x coordinate of the position at time t equals 4. I think that's what we just did. So again, if you didn't get that, go back and try that on your own now. 3a. So let's see, if I want to find stuff about the x coordinates, that means I have to take the antiderivative of dx dt, which is 3 plus the cosine of t squared dt. And I want to know about 4, and I know about 2, so I'm going to go from 2 to 4. I'm going to keep those in order so I don't have to worry about negative signs. And then that's going to be x of 4 minus x of 2. Right? Because taking the antiderivative of dx dt gets me back to the x function. And we know this, that what is it? It's 1, right? This is 1. So x of 4 will be equal to whatever this is plus that. I'll write it down, why not? That's 3 plus the cosine of t squared dt plus x of 2, adding that to the other side. All right, let's do that. So I want to do math 9 fn int of 3 plus cosine of x squared comma x comma 2 comma 4. And then the x coordinate x of 2 is 1, so I'll add 1 to that. Of course, that just makes it a 7, right? So that's 7.133. 7.133. Great. Getting good at that. Part B, at time t equals 2, the value of dy dt is negative 7. Write an equation for the tangent line to the curve at the point x of 2, y of 2. So when time equals 2. Well, let's see. I need a point, which they gave me. They told me that the point at time equals 2 is 1, 8. So my point is 1, 8. And the slope is dy dx, or in other words, dy dt over dx dt. So they told us right here dy dt is negative 7. And dx dt, when I plug in 2, well, dx dt is this. So that would be 3 plus the cosine of 2 squared, whatever that is. Right? So, I don't know, I guess we want to find a value for that, I suppose. It's not any nice number, so let's see, what's negative 7 over 3 plus the cosine of 4? I'm just going to check really quick and make sure, yeah, I'm in radian mode. So that is negative 2.983. So my line is y minus y is equal to slope times x minus x. There's your tangent line. Okay, find the speed of the object at time 2. Well, I think we've got the pieces, right? We've got, it's at the same time, time equals 2, so the speed is just the Pythagorean theorem on these two numbers. So speed is equal to the negative 7 squared plus 3 plus cosine of 4 squared. So let's see, that's the square root of 7 squared, I dropped the negative because it's going to turn out to be positive anyway, right? Plus 3 plus the cosine of 4 squared. That's 7.383. 383. That's the speed. They didn't give us any units here like meters and seconds, so units per time, I mean, there's nothing we can really do there for units. So watch out, though. Sometimes they do give you units. All right. For times greater than or equal to 3, the tangent line to the curve has a slope of 2t plus 1. Let's read that again. For times greater than or equal to 3, the tangent line has a slope, in other words, dy dt over dx dt, right? That's what that means. That's the slope, is equal to 2t plus 1. And they want us to find the acceleration vector of the object at time 4. Okay, so let's see if we can do that. It's a little tricky, but I think we can manage that. So acceleration at 4 is equal to the second derivative of that at 4, comma, the second derivative of y, but we don't know what the second derivative of the y function is now, do we? We just know that dy dt, well, let me write this down anyway. So we want the second derivative here at 4. Okay, now let's go ahead and do the easy one first. We know that, so the second derivative of the x function, we already have its first derivative. It's the derivative, its first derivative is 3 plus cosine of t squared. So its second derivative, the derivative of the 3 is 0, the derivative of cosine is negative sine of t squared times the derivative of what's inside. All right, so we just need to plug 4 into that. So that at t equals 4, the second derivative is equal to, I'll just write it down like this now, we'll evaluate it in a minute. So it would be that, right? Okay, now the second derivative of this is equal to the derivative of the derivative, right? And they told us a minute ago here that dy dt is equal to 2t plus 1. We could rewrite this like this. dy dt is equal to 2t plus 1 times dx dt. Right? Well, I'm going to use that. Actually, I'll just do the work on here. So I want to find the second derivative of this. Well, the second derivative, so I need to take the derivative of that using the product rule, right? The derivative of the first is 2 times the second plus the first times the derivative of the second. So this gives us a recipe for finding the second derivative, the y function at 2. So let's see if we can do that. At t equals 2, that's 2 times dx dt. I think we found that somewhere along the way, right? Maybe we didn't actually plug that in. 2 times, that's 3 plus the cosine of 4 right? Maybe we did find that, I don't remember. And then when t equals 2, this would be 5 times the value of this when t equals 2. That we just found, right? That's this. So that would be 5 times negative sine of 4 times 4. That's the second derivative. All right? So I think we just need to evaluate these things now. Go ahead and try this one since we're looking at this page. So this is the acceleration in the y direction. It's 3 plus cosine of 4, like that, plus 5 times negative sine of 4 times 4. So this is 19.829. And then the x, we found it's just that piece, right? It's just negative sine of 4 times 4, which is 3.027. So the acceleration vector at time 4 is equal to 3.027, comma 19.829. All right, so that was a little tricky with that sort of weird information they gave us here. But just write down what you have and do the calculus that you know, and it should get you to the answer. All right.